Welcome to EasyBTech channel. Myself Ravi Kumar. In this video, I will discuss about the star to delta conversion as well as delta to star conversion. This technique is very useful to reduce the given network problems. First of all, I will show you the formulas to change from star to delta connection. For example, I consider the star connection is the ending point of any three elements are joined together. Consider three elements is R1, R2, R3. R1, R2, R3 are called the resistance of star connection. Then ending point of three elements are joined together to form a node, and other ending points of three elements are connected to the other elements in the given circuit. That connection is called the star connection. Then we know the star connection. Then that star connection you can reduce into delta network. Then in the given problem, the star connection you can replace with delta network by taking every resistance between the node points. Then it will be a closed circuit like that. That resistances we are taking, for example, RA, RB and RC. The values of RA, RB, RC delta network. It is a closed network. Then here we know the values of R1, R2, R3. Then we can find out the values of RA, RB and RC. Here in easy way how to remember the formula. Here nothing but then what is the opposite element for RA? That is R3. Similarly, what is the opposite element of RB? That is R1. What is the opposite of RC? That is R2. That means opposite values of the known elements. Okay. That means here, if you find out the value of RA, that means here you can mention the formula for RA is, remember in the denominator value, you can mention the opposite known resistance. Okay, R3 is the opposite value for RA. Then in the numerator, you can mention the multiplication of addition of two elements. That is R1 plus R1 into R2 plus R2 into R3 plus R3 into R1. Okay, two elements should be product and adding them. So that is the formula for RA. In the similar manner, you can find out the formula for RB and RC also. That is for RB. For RB. RB nothing but what is the opposite element for RB? For RB, the opposite known resistance value is nothing but R1. That's why in denominator, you can mention the opposite element for RB. That is R1. Similarly, for RC element, the opposite resistance will be R2. Then the value of numerator will be same throughout the formulas. Okay. Remember, the numerator value is multiplication of addition of two values by opposite resistance value. Okay, these are the formulas to change from star to delta. If you know star connection, then you can find out delta connection. In the similar way, if we know the value of in similar way, we know the value of delta, then you can find out the value of star. Okay, that is called the delta to star conversion. That means we know the values of RA, RB, RC, then you can find out the values of R1, R2, R3. Okay, how to remember in easy way? That means for RA, for R1, what are the side values? RC, RA. For R2, side values of RA, RB. For R3, side values of RB and RC. Remember side values. Okay. Then to draw the value of R1. Then in the denominator, you can write down addition of three elements. That is RA plus RB plus RC. What about numerator value? That is product of side values. That is RA, RC. For R1, the side values of RA and RC. Then similarly for RB, what are the side values for R2? To find out R2 value. Side values are RA and RB. Then the denominator value is same. That is addition of three elements RA plus RB plus RC. Why? Because it is a delta connection. In delta, current will be same like that series connection. That's why in series connection, the total value like that here addition of all elements. That's why in the denominator you can mention addition of three elements. For R3, what are the side values? That is RB into RC. Okay, these are the formulas we can use to change delta to star connection. Okay, then how these formulas are applicable to the given network. Okay, for example, we are taking one problem here. Find out equivalent resistance. Okay, for the given example network. Here 555, that is in the given circuit, this will be form delta, or 523 form a delta. Okay, this is a triangle shape, or above also triangle shape. You can change any triangle shape into star connection. Okay, I will show you how to change here. In the given problem, you must mention the star connection inside the given delta connection. Okay, this is given delta. For example, the values are 5, 5 and 5. And below also we have two elements, that is 2, 3. Okay, then inside delta network you can form the star network. Okay, here you can form a star connection between two joined elements. Here 5 to 5 will be joined, then one element will be come out, and between these two elements one element to be come out, and between these two elements one element to be come out. Okay, this is the star connection. Okay, this is one node will be formed. Okay, for example, I take here R1, R2, R3 here. Then you can change the delta into star. Then we have to find out the values of R1, R2 and R3. So this is the given problem. Okay, inside delta you must mention the required star. Then you have to find out the values of the star connection. Okay, we know the formulas here again. What is formula for R1? How to find out delta to star? That means R1 is nothing but the side values by total values. What are side values here for R1? 5 to 5 by total value 3 elements, 5 plus 5 plus 5, that is 25 by 15. Okay, the value is nothing but 1.667 ohms. Okay, similarly R2 also, here the given delta is equal values, all values are equal 555. That's why we are obtaining same values 1.667 ohms. Similarly R3 will be 1.667 ohms. Okay, then after finding the values, then you can delete the delta network. Then what circuit formation here? This is the star after deleting the delta. Okay, then this will be star. The what are the values here? 1.667 ohms, 1.667 ohms and 1.667 ohms. Okay, then what are the remaining circuit here? Then the remaining circuit will be 2 and 3. Don't disturb the remaining circuit here. And also don't disturb the node points where you have to find out equivalent resistance. Okay, here we have to find out the equivalent resistance values between these two node points, this node point and this node point. That's why in our calculation the node points must be present. Don't delete that node points. Okay, then here after changing to star connection, what is the changes available in the given problem? That is here, this value is nothing but 2, this value nothing but 3 here. Okay, na? Observe here 1.667 and 2 and 1.673 both are forming series connection. That's why this circuit you can change like that here. Two elements can be formed like connection like that here. This is 1.667 and one element is 2 plus 1.667, that is 3.667. Similarly 3 plus 1.667, that is 4.667. Okay, at this node point you have to find out equivalent value. Then how to change this here? 3.667 and 4.667 both are in parallel. 3.667 is parallel with 4.667. Okay, na? Then that equivalent value is nothing but 1.544 here. Then the given network will be changes into, that means that equivalent value, that 1.544 in series with 1.667 after changing the parallel connection, then the equivalent value becomes 3.21 ohm. Okay, like that we can use the star to delta or delta to star network to reduce the given network problem. After changing the connection star to delta or delta to star, the given network must be changed into either series combination or in parallel combination. By applying the rules of series and parallel, then we can find out the equivalent resistance values. Please subscribe our channel and share to your friends also.